This is a technical video. It's a teardown of these devices. It's not promoting them in any way. I just feel I have to mention that because sometimes YouTube can be a bit trigger happy. Let us continue by opening this item. So these appeared at local newsagents. And it's an interesting, it's always nice to get the different versions and compare them electronically inside because the quality of these devices is usually quite good. I didn't realise that these were made by a company called JT International. And if you look that up on Google, it's a very, very interesting. It's Japan Tobacco. And it's huge. It's a huge company. Oh, sorry. I'm supposed to give you the experience. Go, oh, yeah. Oh, it's such a package for what it actually is. So this is, as you probably guessed, it's a Japanese, because it's a Japanese company, it's a Japanese fog stick. You get the device itself. You get a charger and a little instruction booklet that basically says, well, when it's just poking out like that, it basically says, it looks like it says up yours. Let's put that out of the way. We're not really interested in this. We've got what we want. And into the pan it goes. There we go. So this is a cartridge-based fog device. And it's interesting because unlike others that have the little USB connector on the end, this one actually is very Japanese. It's got that feel of a Japanese product, that everything is quite well engineered and it all goes click, click, click. For example, it's got a couple of magnets here, and when you put it into this holder, it snaps in. It really just clicks in decisively to charge. And it doesn't matter which way around you put it in, it will charge. Likewise, if you take a look at the cartridges that it uses, there are another two magnets inside here in the contact system. I have investigated one of these before. I feel I should mention that because you'll be saying, how come he knows so much about it? But this video is about taking it to bits and seeing what's inside. So this has a metal base with under its little silicone cap. And this one is full of undesirable liquid that can be got rid of. I can tell you already that I've already investigated these cartridges in the same way as the Canon ones. The Canon ink cartridges. You can drill a small hole, 1.5mm hole, and you can remove the liquid that's inside and replace it with something less offensive. So this is the metal base, and when you put it into the end, it just clicks in nicely. It's a really nice feel for a product like this. It's got that Japanese, everything clicks together with magnets feel. However, if you work in an industry that involves metal swarf, that could be a pipe fitter, electrician, drilling metal boxes, or cutting channels in bus bar chambers, or putting threads on conduit. Any swarf in your pocket, if you put this in the pocket, will stick to the magnets through the casing. It's not great for technical people, but that's okay. So let's pop that in, and yeah, okay. I'll tell you what. Well, give me a moment. I'm going to get a cartridge that doesn't have that stuff in it. Here's one I filled earlier. You may see a slight dimple there where I've drilled a hole and put a bit of sellotape over it. There's plenty of room for this just to go click. There's in same way. And it produces, well, it produces fog as a Japanese fog stick should. Let's go further. So to open this, I see a plastic trim down the side of this. Let's zoom down on this. Let's get a little bit closer. I see a plastic trim. I have tried pushing the end of the other one. It didn't seem to be giving. I wonder if this plastic trim hides screws. So this is where I completely wreck one of them, but then that is the purpose of this channel. Plastic trim. Oh, I can see metal pins. Could they? Hold on, that might push right through. Hold on. Let's get this one off as well. I feel like I've desecrated the trim. Oh, tell you what, I'm going to try and push that pin out. That could be a locking pin that goes right through from one side to the other. Let's get my pin pusher. Little round bit for a screwdriver set that pushes pins. I think it's designed for like watch pins and things like that. Oh, is it going in? Oh, it's moving. Oh, it just popped in, but I was thinking that was going to pop right through, but I think let's pop that in. Oh, okay. What now? Do I have anything I can actually... Oh, it's pushing out. It is pushing out. Let's just shove a screwdriver up the end and push. And it's popping out. It's held in by those two pins. That's quite neat. One of the pins has just dropped out. Nice. There's the battery. The battery it claims is 350 milliamp hour. I've not tested that yet. I shall test that. And it's held in by a bit of Kapton tape. There's also a little circuit board down the other end. It's got components on it. The one at the charger end, the connector end. Let's get the battery out. I shall hook my screwdriver under here and just burst the Kapton tape. Keep in mind that, well, this isn't a fully charged battery. I should expect it's shipped with a half-charged battery. Is this going to come out? Yes, it is. Okay. So there is a little circuit board down at the end, and it comes out. It's only got two components on the back. Looks like a resistor and a diode, but I could be wrong. Let's investigate further. So let's get this. I'll tell you what, I'm going to pause momentarily. I'm going to take some pictures of these. I'm going to pop them out and then show you afterwards. I'll be back in a moment. Back again, thoroughly reverse engineered. We're going to have to zoom down for this because I want to show you how this goes together because it's very neat. All this high profile ones associated with big companies that I've taken apart have been very neat. And certain things like, for instance, this little sensor device, which isn't actually switching the heater, goes into this little recess here. It's attached to the circuit board, but goes into this recess, and then it's got a port, a complex channel to make sure it doesn't get liquid into it. The circuit board also has an LED behind this little dimple that when this is actually put in here, it diffuses the light, and when it's slid into the case, it covers a large area. It means that alignment isn't so critical, though alignment is actually very precise in this, and it makes it glow. It's a white LED. I could have shown you the white LED, but I didn't show you the white LED. Where are the tweezers to get that back out again? No, I'll tell you what, I'm just going to leave it in. We'll tell you what, I'll take that bit out. Other things worthy of note, actually I will take these out because the construction of the connections is very, very impressive. It's got these tiny little gold pins that are spring-loaded. You're not necessarily going to see this. I shall try and hold it in the tweezers, and then I'll pull the wire and you'll see the wee pin goes down. It's got a spring inside that when the cartridge goes in and pushes down the pin, it actually pushes those wires down. And these little gold inserts get pressed in like this. They get pushed into the casing from this side. I'm trying to do it with the magnets right next to it. They get pushed in. Is that pushed in? Yes, it has clicked. I'll push the other one in and show you this. Because the waterproofing, this is not a naive product. This is quite a lot of research has gone into this thing. It is very, very pleasing. The circuit board, which I'm going to show you, I'll reverse engineer it completely, is also very pleasing because it's a nice logical design. So once those pins are in, then this little silicon seal hooks across like this, folds round and locks in, presses down, and the pins stick up through that seal, but with a little sleeve so that they can easily make contact with the cartridge that goes in like this, and you can see the magnet there pulling it into position. These are also very interesting. I'll show you because I took a cartridge to bits. I'll maybe take another cartridge to bits to show you how they come apart because it is very neat. Here are the two circuit boards. I'm going to have to show you a zoom up on these. The pins do, when they push the pin in the side to lock this, it goes into a sort of recess inside, but you can push it right through and it drops inside, as happened for me. But I tell you what, it's time to bring in exhibit number 1 on that tiny little circuit board. Let's take a look at this side of the circuit board first. If it looks a bit grainy and blurry, I shall try and focus down onto that. Focus down onto the grainy blurriness. It's because the circuit board is very, very small. So to scale it up to this size, it did lose a bit of detail in the process. Components worth mentioning. This is a battery protection chip. The battery itself, which is currently on charge to test it for its capacity, it has no built-in protection. It's all on the board. So we've got a charge controller, TP4054 style, that matches the pin out of a charge controller with that little resistor that sets the current, the charge current. And then this here is the little battery sense chip that actually detects if the voltage is too high or if the voltage is too low and cuts it off completely. It also detects short circuits. And that has a little 100 ohm resistor and a little decoupling capacitor just to, on the sense pin, that measures the voltage just to make it immune to the sort of fluctuations of the load battery caused by sort of spiky loads like heating elements coming on. Other things worthy of note on this side, it's got this Mosfet here that is being used to switch the heater. The contact board at the bottom that makes contact with the charger, so that's going down onto these pins here. The middle pin is positive, the two outer ones are linked, they're negative, and the same in the circuit board, you can see the outer ones are linked here. It has the middle contact for positive. I'll switch on to the next picture. It's the best bet here because it will show you what's what here. And then I'll show you the schematic. There's one of the little poco pins, the little contact pins that connects onto the cartridge. Just to show you the engineering is lovely in it. That's the back of the battery, the charging contact circuit. And it's got a PTC thermistor in series, and then what looks like a 9-volt Zener. I tested it, I ramped the voltage up slightly until it started conducting. It started conducting around about 8 volts. This must be to do two purposes. If you connect something that's the wrong polarity, if you've got a faulty charger, this battery will effectively shunt that, and this thermal fuse will then trip. If you connect it to some smart charge charger that then malfunctions and just sends out a higher voltage, if it's too high for this unit, this Zener diode will start conducting once again, the thermal fuse will trip. Nice little bit of protection there. This thing, marked rather suspiciously and anonymously 19A2, is a custom program microcontroller. The thing that's missing from this picture here is this little sensor here, the tiny little microphone-like device that isn't actually a microphone, it's a little pressure sensor. And it has 3 pins. It's got plus, minus, and G, which is a signal back. And that connects onto here. So that little microphone thing was sitting up here above the microcontroller. Other things worthy of note, we've got the white LED here with a resistor in series. And then these resistors are for monitoring the charge. That's about all I can say about these. I think it's time to go straight to the schematic. And then after the schematic, we'll take a look at the cartridges, because there are 14 components. It is very, very complex. Let's start off the power circuitry. There's the little charge contacts. There's the PTC thermistor. There is the Zener diode. And this dotted line indicates the 2 wires that are coming. So that's one little circuit board. It's the tiny little circuit board that I can't even find. It's so tiny. It's somewhere here. Yeah, I've lost it already. It's tiny. That little circuit board is the separate one, but then it comes up to this main circuit board, and I've divided it into 2 here. I've got another page to show you the microprocessor. So this is purely the power. So this is a TP4054 type chip. It's actually marked, what is it marked? B19. And the other chip, the protection chip, is marked 5556A. Oh, there's the little circuit board. They're tiny. They were very frustrating. Probing around with probes on this one was extremely difficult because it uses the smallest little resistors ever. Tiny ones that aren't marked because they can't print on such a small component. So, a couple of things worthy of note here. There's a protection chip in series with the lithium cell. It basically cuts the negative cell away from the circuitry when it gets exceeds about 4.2 volts or drops below about 3 or probably around about 2.5 volts lower cutoff. It's got the 100 ohm resistor and little capacitor to decouple any sort of spiky noise up there just so it can get a nice steady reading. The TP4054 has one little resistor that programs the current. I can show you that on the circuit board it's that little resistor there, and it seems to be roughly about 2000 ohms. I wrote 2K2 because that's a nice standard value. It's quite hard. I had to measure it in circuit. That skews the results a little bit. So that sets the charge current. The other thing it's got is a pinout which indicates when it's actually charging the battery. The other thing in here is a bridge of resistors 10K and about 19K, roughly 19K, that indicates the microcontroller when it's actually hooked onto the charging base. So when it detects power there, it knows it's charging, and then it detects that signal there, it knows it's actually still under charge, because once it's up to about 4.2 volts, that will cut off. The next page shows the circuitry itself. This is so quick to show you, it certainly didn't, it took a lot longer than this to actually reverse engineer, being so tiny. So now we get the battery supply and the microcontroller, MCU. It's got a 5 ohm resistor going down to capacitor just purely to isolate its line. It decouples it from any spikes on the main supply line. So that gives it a stable supply, but that's also used towards the little module that I've called Suck. That's that little microphony looking thing with the diaphragm in it, which is connected to the 1K resistor to the MCU, the microcontroller. The microcontroller controls the LED, the white LED, via a 470 ohm resistor. And when it detects Suck, then it sends it pulls this line low, negative. Now this is a P-channel Mosfet. I shall write P-channel, which means that you pull it negative to turn it on and positive to keep it turned off. So it's got the classic 10K resistor pulling it up to the positive rail to actually keep it turned off, and this 100 ohm resistor that when the microcontroller wants to turn it on, it pulls that low and this turns on, and that passes current through the heater in the cartridge. It also, the heater, it's quite odd, it has a diode across it, and what comes to mind there is that maybe that's a back EMF spike protection, not really sure. Or is it for some, I'm not really sure why that diode's there. I mean, I suppose there could be inductance in the heater, but they've got a diode across it anyway. Strange. The other thing comes to mind is if the polarity was connected the wrong way around, that might effectively shunt the heater, and that would protect it from like heating up. It would actually trip their test power supply. I don't know why that is, but it also senses the top of the heater here. It looks for it actually, when it turns on, it's expecting that to go from being tied down low via the heater, it's expected to go from negative to positive. And I'm guessing it's using that to detect if there's a short circuit in the cartridge or something's bridged the pins in there. And if it does detect that, then it will indicate, it will turn the transistor off and go into some sort of safe mode. It's got other two inputs. It's got the power input that detects when it's being plugged into the charger. That was the bit I showed with the resistor bridge. And then it's got the charge input to tell it when it's charging. Now, when it is charging, when you plug it into charge, the LED very gently fades up and down, and when it's fully charged, the LED light's static. But the downside of that is that you have to actually watch it for a while to see if it is still ramping up and down, because it's quite slow. So it's very hard. You have to actually, it's not a case of glancing at it and seeing LED's gone out, it's charged. You have to actually watch it and see if it is ramping or not. That is it. It seems so simple. It took a while to reverse engineer. That was quite a task, particularly given the size, but very interesting. Not sure what this is. I thought it was an AT-Tiny, but unfortunately the only AT-Tiny, the first one I came across that had 5 pins, it says do not connect to the 2 middle ones. It was like basically an 8-pin device in a 5-pin package, but these ones are being used. They've all got functions. Let's go on to the heater cartridge. I could show you now. Do I take one of these apart? I do take one of these apart. So let's take apart the one that I've already drilled a hole in, so that we can I can take it apart without, well, it's going to spill liquid everywhere, but at least it's not got the N word in it, that nicotine. One moment. A bit of kitchen towel in the vain hope it's going to what I should really do is I should suck this liquid back out of here with a syringe. One moment, I'll do that. a standard syringe, one of the sort of ones that's used for electronic purposes, with the really short blunt needles. This is my 50/50 with a little touch of menthol, and I can actually just, I drilled a hole in this earlier on, 1.5mm diameter, and all I've done is fill it up with a syringe like this, and then put a bit of, wiped it dry, and then put a little bit of sellotape over it, because that's fine. So I can just punch this through that hole, and I can soak it right back out again. And that'll save me making an absolutely huge mess on my bench. This reminds me of refilling the Canon inkjet cartridges. They used to be so easy to refill until Canon just decided to chip their cartridges. And I don't know if you guys are aware of this, but the Canon, when they chipped their cartridges, if you used an unofficial cartridge, it would, one that had been chipped by another manufacturer, you know, the sort of refilled, the recycled cartridges. Canon disabled features in the printers. Like if you went to scan it, it would say, because the cartridge, the ink cartridge isn't real, in this it's not an official one, you're not allowed to scan. And that's the point me and Ralph stopped using Canon printers and switched to Epson, who had at that point grown up and allowed their, the EcoTank system, where you have the bulk ink printers that you basically just pour in bottles of ink into the reservoir at the side. They're great. So this thing, to open this, you kind of have to get a screwdriver at the side and prise it up, because it has little little dimples at the side, little catches. I'll zoom down on this so you can actually see it. I should also actually, hold on, let's bring a target to give it something to focus onto. This is where the focus usually goes horribly wrong. One moment. Is that looking crisp? Just give me a second, I'm just going to look at that. That is not too bad. Yeah, that'll do. I want it to be in focus so you can actually see what happens. So it's got this little catch here, and if you prise with the screwdriver, you can lift that up. Once you've lifted the metal cover off, this is the bit that also snags onto those magnets. You've got the base here, and it just slots in. It's got a seal around it. It's very, very neat. And it's got the other mating part of it that comes out here. I should keep the paper towel handy for this. I'll show you these in more detail. I took one completely to bits. I can more or less show you that now, but this comes out, and that's, I suppose that's the way you could refill it. You could basically sit this back on here, the heater or wick assembly, and then you could fill this and pop that back in, but I don't know how many times you'd be able to prise this bit off. This bit also, with loud creaking plasticky noises, it also comes off. This is where I will impale myself at some point. Yeah, you know what? I've already taken one to bits. Why am I doing this? Look at the, I'm glad that is not the nicotine stuff. I just said the word nicotine. That's a keyword to YouTube. That probably means it's being demonetized, at which point I say thank you to the Patreon supporters for allowing me to make videos like this with keywords in them that probably will get demonetized, but because of Patreon I can still make videos about things like this without worrying too much about that. Right, hold on. Yeah, that is gooey and sticky. One of the things about glycerin and propylene glycol is they're humectants. They're used in skin creams. If you've got hard skin, rub of that on it will help, because it sort of it absorbs moisture out there. Right, let's zoom out a bit and bring in some exhibits, because you're going to be very, very impressed at the engineering of this cartridge. Look at that for a start. So looking down on the cartridge, you can see it's got the metal shell, and then it's got the heating element. It's got 8 turns of this heating wire, and then the fibre through it. And when you put the other cap on this, that bit there on top, the only way the liquid can get out of the cartridge is to wick along inside that. So it only gets in as it's needed, and it pulls a slight vacuum inside the cartridge itself. The components are quite tightly wedged in. I had to break this to get it out. The heat element, if you look very carefully, I'll zoom down a little bit, you might be able to see this. Can you see the little weld there? They actually have spot welded on each end of this element. They've spot welded a little wire. And when this wire goes down into this metal shield, and the metal shield has, can I show you this? The metal shield is these sort of recesses. Again, I should be focusing down onto here, shouldn't I? It has these recesses at the side that everything just sits into. It's the first time I've seen a proper metal housing in these disposable cartridges all round the heating element. That seems a good idea. So this is pressed down into this housing, which is sitting there, and then this silicon insert is poked from the other side. Can I show that here? It's poked from this side, but you can't really see it. All you can see is a little dimple in the middle. And then these gold pins. After that's been, let's try that again. The silicon insert's poked in through that. Then this is pressed down, and these two wire tails go through that silicon insert, and they're folded to the side, and then these gold plated pins are shoved in, and they make the electrical connection onto this that then powers the heating element. This silicon cover then sits around the outside of that. It's a seal, in many ways. It seals to the side when that's inserted back into the tank, but it also seals onto that bit, which is onto this middle bit here. I did strip one of these apart. I've just got cartridges everywhere now, haven't I? There we go, that's better. So there's the plastic cartridge with a hole in the side where I drilled another hole for refilling and a bit of tape over it. When you sit that into the, I'll just tip all the bits out, such a mess. When you sit that into the black mouthpiece, there's actually another little silicon seal at the end that actually mates on the end of that, presumably just to stop liquid oozing down the side. Complex. But this is the air pipe that you're pulling air up, and the air comes in through the base of this, in the base here, past the heating element, and then this little silicon seal stops the liquid coming in from the sides and only lets it draw up the middle past this heating element, which is then, of course, it's atomizing the glycols by causing the water in the glycol to actually atomize, and it shatters the glycol apart into tiny little droplets. That's what you're actually seeing, is tiny little spheres of glycol being drawn out of the thing. It's a very, very neat assembly. A lot of work has gone into designing this, but then you'd expect that given the sort of market it's aimed at. It is like aimed at serious ingesters of vapor. That feels like it's all suddenly come to an end. I'm just actually mulling through in my mind of how this, if I need to say anything else. The main thing about these, if you've got one, and they won't approve of this, but 99.9%, well 99.999% probably, of people who use these will just throw the cartridge away. It seems a waste when you see what's involved. Those who don't want to throw it away, want to refill it, can either take that bottom off by liberating this metal cover and then just sliding it out, or the easiest way by far is just to drill the 1.5mm hole in the side, just off center, and then squirt the liquid in, and then put a bit of tape over it, but wipe it first, because otherwise if a film of the liquid gets between the tape, it's just going to make a bit of a mess. That said, the design of this assembly in here is such that it is designed to deal with a slight leakage. It's quite good. The air intake is also at the sides. It seals everything from going down. There's no easy path through this. There's just one tiny orifice down here that's designed to allow that differential of pressure for the microphone type device to actually pick up the fact that you are inhaling. But it's neat. It's very neat. As you'd expect, it's one of the more slick units I've come across, and it's very much a loss leader because they're charging £4 at the local newsagent for that, but then the cartridges, of course, it's more like £5 or £6 for 2 cartridges, because they're then aiming at the pack of ciggies type sort of pricing. But there we go. It's interesting. It's the first time I've seen them using the dedicated little charger, I think, here. And note that the spring, the little springs for strain relief, it just seems so nice. It seems like an interesting design. What would happen if you shoved that down there? Nothing. Okay, because it wouldn't actually make any sensible connection with the contacts. Could you do it to the side? No, just short it out. Maybe they thought of that, actually. But there we go. Interesting. Well worth taking to bits, and it's probably one of the slickest and most well-designed ones with logical circuitry that I've seen so far. It looks pretty good.